the fourth space vehicle in NASA's Skylab program, was moved to the launch pad at Kennedy Space Center in August 1973. The move was made at an early date so that this Saturn rocket and its spacecraft could serve as a potential rescue vehicle for the second manned Skylab crew. The space vehicle remained in a launch-ready condition at Pad B until the end of the 59-day mission of the second crew. In November, the Saturn rocket was prepared to launch the third Skylab crew to a rendezvous with the orbiting space station.
Well, the major objectives of the third mission are essentially the same as that of the first two, the three general tasks. The first being that of medical flight physiology, the second major task being that of solar observations, and the third major task being Earth resources observations. Since our flight is a winter flight, we'll probably have a lot more snow cover data. And the hydrologists are particularly interested in snow cover and its effect on the nation's water supply. We'll have an opportunity to look at snow cover in Japan on Mount Fujiyama, and we're going to have a chance to look at some of the problems that are involved with environmental pollution as a result of winter heating in several areas of the world.
Well, the title is Science Pilot. Now, what that means is that I should concentrate and have concentrating in those areas which involve both medical and the operation of the solar telescopes.
Dr. Edward Gibson, 37, science pilot. Born in Buffalo, New York, Gibson is a specialist in solar physics. Since joining NASA, he has written a textbook on the subject.
The book is entitled The Quiet Sun, and what prompted me to write it was to learn a little bit about the area of solar physics. The best way to learn something is to try to explain it to someone else, so that's what I sat down to do. I think we've been and are going to be exceptionally fortunate in being up in orbit at the same time Comet Kohoutek will come by. It's rather fortuitous, but I think very lucky for science, and in particular for the people who want to understand how the solar system was formed, and for people who are looking for primordial matter. As you know, in the Apollo program, we've selected a lot of landing sites hoping we could find old matter which has been around since the formation of the solar system. We found what we thought was fairly old matter, but we never quite got there. The closest it will get to Earth is a little bit less than the distance between the Sun and the Earth right now. It will be very visible from Earth. Before the November 28th, it'll be visible in the morning sky. After the 28th, it'll shift over and be visible in the night sky. And that's also after the 28th, which is the distance, or the time when its distance is closest to the Sun or shortest. We'll be able to see it in the night sky quite vividly. It'll be a very bright ball or bright sphere with a long tail going off for maybe covering a third to one half of the sky. And I think it's going to make a very dramatic evidence of what Mother Nature can really do. People are still talking about Halley's Comet, and I'm sure this is going to be as dynamic, perhaps more so than that.
We have a facility on board called the Materials Processing Facility. The experiments which are a part or use the Materials Processing Facility primarily to give us a sort of an infant step in the direction of seeing what it is that we can do in the way of manufacturing materials in space. Another area which has already been fairly well pursued is the zero-gravity welding and brazing materials, sphere-forming experiments, and we are now looking at the data from those experiments. Sphere forming, we were interested in seeing exactly by heating a small pellet of metal to a molten state how well the surface tension would pull that into a perfect sphere. We're still looking at the results from that. Toward the end of the mission, we will actually conduct flammability experiments as we'll ignite different samples. We'll ignite samples of aluminized mylar, Teflon, neoprene rubber sheets, paper, ordinary garden variety paper. Some of them will be single sheets, some of them will be sheets that are close together so that we can see if the flame actually transfers from one surface to the other.
Gerald Carr was commander of this, the final Skylab mission. William Pogue was pilot. And Dr. Edward Gibson was science pilot. None of the men had been in space before, but on this 85-day mission, each of them would set endurance records for the longest time spent in space flight. Liftoff of the fourth Skylab vehicle was delayed for a week when hairline cracks were discovered in the rocket fins. With the fins replaced, final checkout was performed by the KSC Manned Launch Operations Team. This Skylab launch would be the last manned flight from Kennedy Space Center until the Apollo-Soyuz mission in July 1975. The third Skylab crew boarded their spacecraft on the morning of November 16, 1973. The countdown proceeded smoothly to T0 at 9:01 a.m.
T-minus 18 seconds. T-minus 16. Count continuing to go smoothly. T-minus 13. We'll look for an ignition at T-minus 2.1 seconds. 9, 8, 7, 6, 5, 4, 3, 2. We have a liftoff. Liftoff. The engine's building up to 1.6 million pounds of thrust, and Skylab is moving slowly off the pad. It's cleared the tower.
We're getting a roll program. Roger, smooth ride. Roger. Mark 18 seconds, Houston now controlling. Program. Roger, steady on. 30 seconds. Pitch and roll program started. Skylab now maneuvering to its proper flight path attitude. Mark 35 seconds, 1 nautical mile of altitude. Mark 40 seconds, given green light by rate safe. Mark 45 seconds, cabin pressure leaving. Adjusting under. Roll complete, pitch profile still in progress. 58 seconds, 3 nautical mile altitude. Mark 1 Bravo. Roger, 1 Bravo. Your feet wet and everything's looking real good. Copy, feet wet. Mark 1 minute 12 seconds. I call out from Capcom Dick Truly, says Skylab now capable of water landing. 1 minute 18 seconds. Passing through a period of maximum aerodynamic pressure now.
The astronauts rendezvoused with the Sky Laboratory as it completed the 1480th revolution of the Earth. Skylab would orbit the Earth over 1,200 more times, while the third crew lived and worked aboard the space station. A fly-around inspection of Skylab revealed that the sunshades installed by the first two crews were in good condition, as were the solar panels, which generate electrical power for the space station. The men docked their spacecraft and then transferred to the Sky Laboratory. Reactivation of the space station was soon accomplished, and the men explored their home in space. Some motion sickness was experienced during their first week aboard Skylab, but the men quickly adjusted to the new environment and demonstrated their ability to move about in the weightlessness of space flight.
This is Skylab Control, Houston. Skylab crewmen Ed Gibson and Bill Pogue are spending their Thanksgiving Day afternoon working outside their orbiting space station on this, their 7th day in orbit. The crew is progressing through a 6-hour spacewalk today, replacing film and solar cameras, installing scientific experiments, and attempting to make repairs to a bulky antenna. When they are finished, the crew will have a hot Thanksgiving Day dinner. This is Skylab Control, Houston.
A daily routine of living and working aboard Skylab was established. It included intensive exercise periods for each man. An elastic harness and treadmill was one device used to help keep body muscles in good shape in the weightless environment. A bicycle ergometer provided a means of exercising, as well as data for several medical experiments. One result of the medical investigations conducted by the 3 Skylab crews indicates that man can live in space for extended periods of time without ill effect. Weight loss and muscle deterioration recorded on shorter space flights were not serious problems on the long-duration missions. In fact, by mission's end, the members of the 3rd Skylab crew were gaining weight. Measuring weight in space required a special unit called a body mass measurement device. The back and forth movement, or oscillation period of the device, is measured and electronically converted to a mass readout.
Small masses were also measured on a device so sensitive it could determine the weight of a postage stamp.
A large selection of frozen and canned food was available for meals aboard Skylab. Individual food trays with heating elements were used by the astronauts. Magnets held the utensils to the tray until used. Individual water guns provided both hot and cold water. They were used for drinking and in the preparation of some foods. Cleaning up after meals included taking out the garbage, which was deposited in a waste disposal tank. The men had a busy work schedule aboard Skylab and accomplished much more than planned. They spent more than 3 times the scheduled hours working on materials and space manufacturing experiments.
We're going to be studying a little bit in the next couple of days. One particular way of forming crystals, which Dr. John Carruthers, one of the people working in the field right now, feels is a very promising way in which to grow crystals with exceptionally pure and uniform properties. This will enable us to create much smaller crystals, or much smaller transistors, if you will, much smaller circuitry, and we think make a improvement in the electronics industry. However, what we're going to be doing has application in many fields. Just plain study of fluid mechanics in 0G, I think you'll see is going to be fun, and it's also got some very basic applications.
The Apollo telescope console was manned 2.5 times longer than scheduled. A large number of solar flares was observed by the astronauts. In addition, by blocking out the sun's disk, the Skylab crew was able to continuously observe the solar corona. Observations of Earth were also conducted by the crew. What does the United States look like from space? This is the island of Hawaii, the Los Angeles area and the coast of California, the Louisiana coast with smoke trails from 2 burning oil wells, the northeast coast from New Jersey to Massachusetts, and the state of Florida with the Bahama Islands at the lower right. Multispectral photography of Earth was also performed. Using 6 cameras with different filters, various wavelengths of light are detected. A new way to maneuver outside a spacecraft was tested inside Skylab. Gerald Carr demonstrated the astronaut maneuvering unit, which is being developed for future manned space missions. The men spent the Christmas season in space and appropriately decorated Skylab for the occasion.
A very unusual Christmas tree, painstakingly constructed out of food cans and decorated by the astronauts with a very special star on top, Comet Kohoutek.
From the Skylab 3 crew, we wish to extend to people around the world a message of peace, goodwill, and human understanding.
On Christmas Day, astronauts prepared to go outside the laboratory to observe the comet Kohoutek. Getting into a spacesuit can be quite a problem, especially when there's not gravity to hold one down.
Dory, we may have grown an 1.5 inches, but our suits haven't.
Okay, Jer, that's a confirmation of what we saw in the anthropometric data. both from the middle line up to the shoulders.
That's sure where it feels like, Story.
Okay.
Be it ever so humble, there's no place like home.
Skylab, we're reading you loud and clear through to Narration for 4 minutes.
Roger, we just opened the OWS hatch. Story, we just crossed in the southeast coast of Australia.
That's firm.
Yes. Tasmania down there, I think. New Zealand can't be far away. Right. What's new in New Zealand? I gotta turn around here and rubberneck for a little bit. Yeah, it's a great time for it. Don't get to do this often enough. Holy cow, what a view.
Skylab, we understood you started SO20 again, and until we get regrouped here on your APCS, I would like you to proceed on with the sun end film replacement.
Okay, we'll do her.
The crew of Skylab 4, Gerald Carr, science pilot Ed Gibson, and Bill Pogue now in their 40th day in space. Establishing a Skylab record today, spending 7 hours outside their orbiting space station in the longest weightless work session in the Skylab program.
The Christmas EVA lasted 7 hours. It was the longest period ever spent outside an orbiting space vehicle. In addition to observing the comet, the men changed the film in the Apollo telescope mount. This was done 4 times during the mission.
Morning at 8:35 Central Standard Time, the crew will reach the halfway point in the scheduled 84-day mission. The space station will be over the South Atlantic Ocean at this time at 8:35 Central Standard Time. At that point, the space station, the crew will have made 607 trips around the Earth, logging 17,650,000 miles in space since their launch from Cape Kennedy on November 16th. Ground controllers continue to review data from the Christmas Day EVA and preparations for upcoming Saturday EVA, devoted exclusively to Comet Kohoutek photography.
Skylab crew passed the halfway point in a planned 84-day mission this morning at 8:35:46 Greenwich, that's Central Standard Time AM. Early this morning, the comet also passed its midway point in its journey. It passed the closest approach to the sun early this morning, and that's on its way away from the sun at this point.
Good afternoon, Dr. Kohoutek.
Good afternoon. I am very glad to have an opportunity to following the Comet 1973F during its most critical day. You observed the comet visually last Sunday and Monday. You compared it with, in brightness with Mercury and suggested that there were color features in the coma. Do you have anything more to say on those observations?
Not too much to add to that, sir, because we have not seen much of the comet visually since those last observations. I can pull that retainer in the hatch. Okay. There it is, the great outdoors again. Right. Zoom work. Hey, I can see the comet. Yeah, look it, right out there, see it? Okay, I can see the tail behind. Holy cow, yeah. Hey, turn the lights off, Bill. Oh, yeah, beautiful. You sure can.
Skylab, we're enjoying your comments. We're 30 seconds from LOS here, about 28 minutes to Carnarvon at 1803. All your systems are good.
Okay, we can see the tail, which is anti-solar, but I cannot see the spike, which showed up yesterday on the photography. Okay, it's just going into the airglow now. Just going into the airglow. Very wide, broad tail. Not very long as well as we can see. We were not too well dark adapted there, Jared. We'll have to make a note of that next time. Yeah. Okay, that tail, I guess, I was looking at 5 degrees or so when I first spotted it. Okay, it's into the air glow now. I suspect that's the reason you couldn't see it the other day, is because it was always in the air glow. Yeah, we got a better elongation now. I suspect you ought to see that out the window. I looked at that looked for it yesterday out window 3 and couldn't see it. Okay, let's press on. Turn the lights on.
The comet Kohoutek. While its observations from Earth were not as spectacular as hoped for, Skylab's solar telescopes plus 2 spacewalks with portable cameras gained amazing results.
Okay, let me tell you about Comet Kohoutek. I got a chance to look at it the night before last, the orbit night before last, and looking at it through the binoculars, I saw it around the tail of around 4 degrees. Yesterday I had estimated to be around 3 degrees, and I did this by just comparing the field of view in the binoculars with something I could see inside and, measuring distances and angles and so forth. It came up with around 4 degrees. I'd estimate a length to width ratio of around 20 for it. That gives you a width of around 233. And again, all this is eyeball. To get its full width around 3 widths back, that is 3/5 of a degree back from the coma. The edges of the tail are very straight from those 3 widths back, and at around 10 or so back, it starts to fade away, and gradually by 20 it's disappeared. I think a lot of it is dark adaptation.
Science pilot Ed Gibson gave a more thorough report on the comet. His observations of it said that it increased in length from about 3 degrees yesterday to 4 degrees today, which would indicate it's about 33% longer, or it's growing in the vicinity of about 2 million miles in length.
Actually, the Skylab instruments were the only means available to scientists anywhere to observe the comet during its close passage to the sun, as this stop-motion film shows. The fact that the astronauts were able to observe the comet at this time and even make sketches proved scientifically valuable in collecting basic data needed to make the greatest advance in cometary research since Halley's time.
Well, the observation of Comet Kohoutek offered an unprecedented opportunity. It was very bright, and most notable was a sunward spike, which was in the opposite direction of the tail, very sharp and pointed towards the sun. Comets are important to science because we are able to observe what we think is primordial matter. That is matter which has been around since the birth of the solar system, if the comet came from the solar system, or if it came from outside the solar system, then it's an opportunity to observe something which was not created with our solar system, but in the regular stellar scheme of things.
Happy New Year, guys.
Happy New Year, Grim.
Boy, what a wild party we got going on down here.
Sounds awful.
That's lots of fun. I figured you guys had been having one.
Oh yeah, we've been up here snorting around.
Terrible way to wake you up on your early day off.
Play our song again, will you, Grim?
We'll save it for you for another good time.
All right. There's my gyro. There's my string, looking to get tangled. Now I'm going to turn this little rascal loose. There. Okay. And I'm going to use these 2 soda straws in order to provide the forces that I need. Now I've got this gyro spinning quite fast now. And now notice when I hit it with a straw or deflect it. See, it moves in translation, does it? Just exactly the way it did before. But you notice that when I hit it, it doesn't want to tumble or drift in rotation. It maintains its rigidity in space.
Commander Jerry Carr is in the command module now, and he's preparing in about 1 minute to perform a thrusting maneuver with 4 small jets in the command module. They're 100-pound thrust jets, and
They are used to make very small and precise adjustments to the orbit of Skylab, and this is to preserve the ground track repetition capability. Okay, I'm going to coordinate now with the crew here and see just exactly how far away from the burn we are. And of course, when the spacecraft moves, these balls that are floating freely in space will not move due to that thrust, but they will appear to move relative to the spacecraft because the spacecraft is moving. 5 seconds to go. Okay, now you see the ball starting to move up, and I'm going to move them back down again. They should move up again. Okay, that's it. All right, the thrusting maneuver is over right now. I should be able to take the balls and float them freely and steadily in space again. And you see it is.
What we're looking at here are the two ends on which I have injected 3 cc's of water each, the one on the left with a red dye in it and the one on the right clear, although it does have some bubbles in it. First I'll move them together. See, immediately surface tension takes over as soon as they hit. Okay, I hope you can see the interface between the two. And we're ready for the rotation. I'm going to try to rotate this so that I'll be moving the bar up, which holds the string, at around 16 inches every 10 seconds. Okay, we're in motion now. Notice nothing really violent. Okay, now I'll accelerate it a little bit. That appears to be about the max we can go.
Experiments submitted by 25 high school students were continued on this mission. Astronaut Gibson explained one experiment proposed by Kathy Jackson of Houston, Texas. This particular experiment was devised to measure eye-hand coordination before flight, during flight, and post-flight.
Hey! Another 45 seconds. Can't beat that. Well, Kathy, hope you learned something. It's been fun.
In early February 1974, the third crew retrieved for the last time the film, magnetic tape, the samples and specimens for return to Earth. The operational phase of Skylab was nearing a successful end. The ongoing science phase, fueled by the aggregate of data from all 3 missions, would last for the next several years.
Line hooked, bracket, lock hook, done. Straight clothesline, done. Rotate base link until locked. Okay, that's in work. You know, Jerry, it's locked. Hey, it's locked. Good. Okay. I hate to tell you this, but the clothesline from point to point describes a perfect straight line through TO-25. Right. We're going to have to really be careful with that. Yep. Back and attach the VS clothesline hooks and lock. I think I will tag clothesline hook first. I'm going to leave this wrist tether on it, Jared. You may need it. Okay, good. And then transfer the DAC to the DT. I'll tell you what else let's do. Let's hook the 2 clothesline hooks together, or we're going to be hurting for slack to work around here. Yes.
This extravehicular activity appears to be going well. The crew is now making preparations, hooking up the transportation device, the clothesline, making preparations to go up and retrieve the SO-82A and SO-82B film.
And down the busted side of the workshop. Okay, because I'll tell you, this is a beautiful view. Looking down the axis of the vehicle with the solar panel and the Earth in the background. Hey, there's our ice island. Hey, look at the blooming. Hey, you know that moving leads right over to the ice island. Yeah, do you see South George Island around there anywhere? Yeah, I think I see it under clouds, yeah. Okay, Story, we got all the samples taken in. We're just finishing up the Nikon work, and we'll be all set to start packing it all back into the airlock. You better start pulling in my umbilical end. Uh-oh. Well, I better get down there where I can do it. Let me get my warm, young, tender pink little bod down in there. Yeah, I've got a few pieces of gear hanging around here. I sure do. Along with ropes, tethers. Hey, this SOP was not made to avoid hang-ups. Okay, what am I hanging up on this? On the clothesline? And what part of me is hanging up? Your whole backside. If someone ever told me we'd be working in this environment 2 or 3 years ago, I would have said they were crazy. No way.
The experiments, the work, and the routine of living aboard a space station continued until February 8, 1974.
Crew is about 7 minutes away from being awakened on their last day in space, last day of the Skylab mission.
Morning, Story.
How y'all doing this morning?
Doing great. We're ready to roll.
What kind of sleep you get?
Oh, I think ranging from not so good to pretty good. I got 5 hours.
Okay, great.
Yes, sir. Still got you for 3 more minutes.
Okay, we're undocked. We released the docking extender release a little too soon and caught on the capture latches. Had to release them and thrust our way off.
Okay, copy.
Crew will now start a fly around of the workshop.
I'll tell you, this vehicle sure looks like it's been worked over.
Well, it's been worked in, I know that.
We got one fold in the sail, the crib that has apparently opened up recently, and it's a whole lot lighter color, a lot whiter than all the rest of the folds in the accordion pleats of the sail.
Copy.
The cryptic can see 2 colors in the sail. That's the sail underneath. One where it was originally covered by the one on top, and then the one on top pulled away a little bit. It's got 2 shades of brown, one very dark and one's just about a light tan.
After setting a new record of 84 days in space, the third manned Skylab mission ended with a splashdown and recovery in early February of 1974.
Okay, the mains are unreefed, open full. Looking good, Trip. What a beautiful sight.
Crew confirms main chute deployment, and they have unreefed.
Go ahead with your transmission.
Read you loud and clear, how many?
Loud and clear. Give us go ahead with your transmission, Tripper.
Oh, I wasn't giving you a call. I was just saying that sounded good to me, too.
Right here.
Splash marked 15 hours, 17 minutes, 55 seconds. Greenwich Mean Time.
Descending downwind from the command module.
Command module is reported in stable 2 position, which means it has flipped over. Command module is coming up now. The helicopter can see one of the uprighting bags.
It appears that the first astronaut to come out will be Dr. Ed Gibson. He's in the center seat and would be the logical one to come out first. I believe we're ready now. Dr. Bichard, Bill Richmond now leaning in, talking to Ed Gibson. There, I can see Ed Gibson in the hatch. Big smile. He's got his cap. Doctors all back out on the platform now. Bill Richmond leaning in with the last word for Ed Gibson. And here he is, coming out through the hatch now.
legs back. Big smile and a wave, and that cheer goes up on the ship. Ed says, I feel great. He's being helped there. He's seated now on this platform. And Bill Pogue is now, with a beard, seated in the hatch and is coming out now. He's seated in the hatch, he's got both feet on the platform. Sit there for just a minute, he stands up rather carefully. He's got a good beard. He's now talking to Dr. Ed Richard. And a smile and a laugh. I don't know what they said to make him laugh. The waves, the cheer on the hangar deck here of New Orleans. Bill Pogue now being helped to his chair. And the ship is rolling just a bit. And he's seated in the middle chair. And now, Jerry Carr's in the hatch with another big beard. He sits in the hatch, he's chatting with the doctors, and they're all laughing. Now he's standing up, big smile, wave and a salute. There is a happy spacecraft commander. Looks up and waves, and now he's being helped to his seat. 3 astronauts now seated on his platform on the forklift truck. Forklift truck will back away from the spacecraft and then move into place by the command module.
The third Skylab crew had completed man's longest space mission, spending 85 days in space.
The fact of the matter is, if man stops really stretching himself and extending himself and looking out, then I think that's when civilization will begin to decline. Man just has that inquisitive nature, and it's got to be satisfied. On our mission, we elected prior to the launch to increase the exercise period from an hour to an hour and a half. And this was done mainly on the basis of recommendations of the previous crew. They felt there just was not enough time for a good exercise period, that you really needed more time. We were also bringing up the little treadmill, which was going to require time for use, so we just ended up going for an hour and a half per day exercise. It appears that that decision was a good one because we came back, I think, in better condition than has any other crew.
First, we've explored the moon, and we've now going to explore near space, and finally, we're going to explore the solar system. All of this, man plays an integral part. Well, the advantages which manned spaceflight offers are in the area of repair and maintenance, which we've demonstrated time and time again on Skylab. As a matter of fact, the whole Skylab series of flights would have been a failure had it not been for the ability of the first crew to repair the space station. The sun turns out to be a giant astrophysical laboratory. It is made up of plasma. That's high-temperature gases, which we plan to use down here for many schemes in energy production. And we can use the sun as a laboratory to better understand how plasmas are affected by electric and magnetic fields, how they're moved, what their properties are.
Space Lab itself, as it is presently conceived, will provide us with a capability which grows on Skylab, expands on Skylab, and provides us with an enormous capability to conduct research in space. We took blood samples periodically throughout the flight, mainly to make sure that the hemoglobin level in the blood was maintained at a proper level and that the body was responding properly to lowered levels of hemoglobin or red blood cells, to make sure that there was not some sort of subtle effect taking place in zero gravity that would leave us more or less open to infection, say. We slept in a sleeping bag-like device, which had straps across it, so once you were in the sleeping bag and all snugged up, so to speak, well, you felt very close to what you feel like in bed on Earth. Also, we have operated very extensive and complex equipment in Skylab and established that this is a viable operation, that you can do it. We have learned from Skylab exactly what features are best, what features to avoid in the way of designing, say, a spacecraft or space station itself, or even certain pieces of scientific equipment.
The Skylab program had answered many questions in achieving all of its mission goals. Man can live in space for extended periods. He can perform useful work on board and make necessary repairs of the space station. Skylab had shown that manufacturing, experimentation, and testing can be conducted in an orbital environment. Studies of the Earth take on a new dimension when conducted from space. In addition, an unrestricted view of solar and celestial phenomena is offered from an orbiting laboratory. Skylab, America's first manned space station, was the forerunner of the next space lab to be flown in NASA's shuttle program. The work projects being planned for shuttle missions will be greatly influenced by the results obtained from the 3 highly successful manned missions in NASA's Skylab program.